Yes, hello. It is time for our fourth video in the season. Ooh, maybe this is a season. In our object-oriented programming tutorials, we'll call this season 2. There will be a season 3 later. And this is about, it's going to explain a bit more about a distinction that we've talked about but haven't really talked about, which is what this public thing is that we keep putting into places. What's the difference between public and something else? And you're going to learn that there are other things. There's public, there's private, there's protected, and then there's what the heck happens if I don't put anything in there. And we're going to provide a little bit of understanding of how that works, and as well as a new key term today, which is called encapsulation. And encapsulation is one of those principles of object-oriented programming that has a fancy name, but is really quite a simple concept. And so remember that anytime you create a method or a variable, you are always able to provide information about accessibility of that method or variable. And up till now, you've usually used public, what that means is that everyone will be able to access that method, assuming they do it properly, of course. So that means that inside the class, you can access it. Outside the class in the package, you can access it. And completely outside your package from a completely different class, if they want to, they can still access that particular method or that particular variable. Private is kind of the exact opposite. Private is saying that only methods within this class, only if it exists inside this class, will it be able to directly access it. Anything from outside won't even know it exists. They won't see it. So going back to a previous discussion we had on Java docs, you don't generally write Java docs for methods or variables that are private because they're not even accessible or visible outside of your particular class. And so something you might want to keep private would be, for example, the amount of cash in a vending machine. You don't necessarily want other people outside the class to have direct access to that variable. It's too easy to potentially get hacked or have vulnerabilities with. And so there are many reasons that we want to keep things private, and this idea of keeping your data private is called encapsulation. And the principle is hide all your data and only give access to that data through methods. So all data. So if you were to create a program fully encapsulated, you would do that. You would hide every single instance variable that you had. Now you still want to have access to those variables in many cases. Sometimes you don't. Sometimes your variable is only going to be used inside your class, but sometimes you still want other people to have access to the variables, like the X and Y coordinate of a robot, for example. And so what you do is you create methods that will indirectly give you access to it. And those methods are called getters and setters, right? A getter would just access the variable and return it to the person who's calling it. And a setter would take a parameter and set the value of that particular variable. Here's a quick example of what that would look like. So here's a class that represents a card. We have a rank and a suit. And you'll notice that the rank and the suit are both private. They cannot be accessed. So if I had a deck of cards, I wouldn't necessarily be able to access that information directly. And so what we've done is we've created methods, 2 setters and 2 getters, that are responsible for putting information into those variables and getting information back out of those variables. And you'll notice that they follow a particular a particular pattern. The setters don't really return anything. They take in the type of variable that they're trying to set, and the naming is just set and then the name of the variable. Set suit, set rank, get suit, get rank. That's particular naming, and that's what if you're going to be doing this, those are the names that you want to follow to stick with convention. So NetBeans is going to help us with encapsulation, and I'm going to sort of jump in there in a moment to show you how it can help you. But just before I do that, I want to talk about a little bit about the why. It's a bit of a hassle to encapsulate your data. I mean, let's face it, you're going to have a whole bunch of methods for getting and setting. And I'll be honest, after the first couple times, after the first assignment, probably the next one, where I'm going to ask you to encapsulate your data, I'm going to be really loose about you having to use them. But in industry, there are reasons why you may want to do that. One big advantage is that if nobody directly has access to your data, you can change the underlying representation of it and not break all of the hundreds of thousands of millions of programs that have used it. A perfect example of that is the string class. So you do not directly have access to how the information is stored in a string. It's stored as a character array. If you had direct access to it, and you wrote programs that directly accessed the string variable and the array inside it, and at some point Java decided, you know what, there's a better way to implement it. Instead of using a character array, we're going to use some other method. We're going to create 255 variables to represent each possible character. If they did that, every single program that used the string class ever would break, because they gave you direct access to the representation and now they're changing it. If instead the only way you had access to it was through the constructor and through methods, then nothing would have to break, because as long as they kept those same methods there, all of the code would still work. It's just under the hood, things are being changed. The car still looks the same, things are changed under the hood, but because you don't really know what's going on there, it's not going to break what you're doing with it. And so that's one big advantage. Another advantage is just the principle of, if you have important data, you don't want to be able to give access directly to that to some other program. Being able to control that access through methods is useful. And of course, the third thing is that there are some variables you create that you don't want to clutter with public access. You don't want someone who's using your class to see all of the internal variables that you're just using for your own internal use, to keep track of information that you don't really want to be visible to the outside world. And so those are all valid reasons for why you might want to do that. So now we're back in our house class, and I'm going to add a very important private integer, which is going to represent the price of this particular house. And I'm going to give it private access, which means that I can only really access this directly within this class, all the things within this class. And so what that means is that if I were to go somewhere else and I were to try to access that price variable, it would not let me. Price has private access in-house. I cannot do it. I cannot get access to it. So how am I going to solve that problem? Well, you're going to solve that problem by, if you want to have that access, creating getters and setters. Now you can do those manually, following the pattern that we talked about. But you can also use in many development environments, it's such a common thing to do that they often have a tool to help you. So here I have a tool called Encapsulate Fields. And when I click on it, it is going to look at all of my variables, not just the private ones, all of them. And I can choose which ones I want to create getters and setters for. In this case, I only want to do it with the price. And so I can click those. I can click on this refactor button, and it is going to go through the work of actually setting up those getters and setters. And look at the pattern: public int get price, and it's going to return the price. And in here, it's going to take in a variable and it's going to assign it. Now, the way that NetBeans did this actually raises a really cool point that I haven't talked about yet, and that's one of scope and ambiguity. So NetBeans named this parameter here price, which just so happens to be the same name as the instance variable up here. And that introduces some weird ambiguity, right? Because what I'm really trying to do here is say price equals price. But which price am I referring to? Am I referring to the price of the parameter, or am I referring to the price of the class? And so there has to be a way of fixing this ambiguity. By default, price is going to refer to the closest the closest variable, right? The variable in the closest scope, and that would be this one over here. So if I want to refer to something in a scope outside of this, I have to use some sort of identifier. And the identifier to represent the class that you're in, this class, is literally that word this. And so this helps to distinguish that the price I want to set is the one belonging to this class. And the value I'm going to give it is the one in the closest scope, which is this coming in. It's kind of a little, I used this a few too many times that time. So encapsulation and getters and setters are an important concept. And for this unit, when you're creating something that's private, I want you to make sure that you follow these rules to encapsulate your data and to use getters and setters when you want access to that data. Once we're past the assignments associated with these videos, then you're going to have to kind of use your own judgment as to what makes sense given the flow and given the level of work, and whether it's for a company or a university or an assignment, as to whether you want to go to that extra work to encapsulate those fields. Hope that helped. That's another tricky object-oriented concept, and there's a few more to go before we're done. But that's it for now. Take care till next time.